So trigonometric derivatives, right? We already know how to take the derivatives of just basic algebraic functions, but what about trig functions? We actually have some rules we have to follow. So let's go through them. The derivative of sine of x is just cosine of x. The derivative of cosine of x is negative sine of x. The derivative with respect to x of tangent of x is secant squared of x. The derivative of cotangent of x is just negative cosecant squared of x. The derivative of secant of x is just secant x tangent x. The derivative of cosecant of x is negative cosecant x cotangent x. So these are the rules you just have to memorize in order to do a couple of derivatives. So let's look at some examples. The derivative of x sine of x. Again, I see this as a product rule. So I'm going to say, well, y prime is going to equal the derivative of x is just 1 times plain old u, v, which is just sine of x, right? Product, so I'm going to put my plus sign, right? Put back my x, right? And then multiply by the derivative of sine of x, which is just cosine of x, right? So my answer will just be y prime is equal to sine of x plus x cosine of x. Yes. All right. Let's look at the next one. So this says y is equal to 4 sine x minus 5 cosine of x plus pi tangent of x. Right. So this is just a sum and difference of derivatives, and so here's a shortcut, guys, that you guys will, it's good to remember so you don't, have to go through this product rule like multiple times. Anytime you have a constant multiplied by a, something you can take the derivative of, that answer will just be the same constant multiplied by the derivative of the second thing. So the derivative of 4 sine of x is just 4 cosine of x, right? Minus, again, this is just a constant, so it will be 5. The derivative of cosine of x is negative sine of x, right? Put that in parentheses, right? Plus, well, pi is also a constant, right? So this will be pi times tangent of x times the derivative of tangent of x, which is actually secant squared of x, and this will be my derivative. Now the answer to clean up will just be 4 cosine of x plus 5 sine of x plus pi secant squared of x. Now I just said a bunch of stuff, and I want you to understand what do I mean, right? When I say anytime you have a constant multiplied by another, derivative, like multiplied by another, stuff, right, or thing, right? It could be anything. It could be x, it could be cosine, it could be any number, right? The derivative of a constant times anything is just the constant times the derivative of that thing. And so that's just a shortcut to remember. And to put it in writing, what do I mean by that? Well, 4 times sine of x, right, is a product. Now the derivative of a constant is always 0, so this will be 0 times plain old sine of x, right, plus 4 times the derivative of sine of x, which is cosine of x, right? These will cancel, which gives you this 4 cosine of x. So that is just something to remember. Anytime you have a constant multiplied by another, anything, right? Any constant multiplied by another thing, right? The derivative of that is just the constant multiplied by the derivative of that thing. Let's look at another example. Y is equal to sine of x plus cosine of x cosecant of x. So again, this is just a product. On the second one, well, this is just a sum, right? But on the second one, this is a product, so we got to be careful, right? So y prime is going to equal the derivative of sine of x is just cosine of x, right? Plus, well, this is a product, And so I'm going to split it up. So I'm going to say the derivative of cosine of x is negative sine of x, right? Multiplied by just pure cosecant of x, right? I'm going to add, because it's a product, I'm going to put my cosecant of x because, again, this is what the rule says, right? In terms of product. And then I'm going to multiply on the outside by the derivative of cosecant of x, which is just negative cosecant of x, cotangent of x. Right. So now I have my equation in this form. I can just go ahead and simplify a couple of stuff. Right. So y prime is going to be equal to cosine of x minus sine of x multiplied by cosecant of x. Again, this minus sign could come in front, so I'm going to put a minus cosine of x, cosecant of x, cotangent of x, right? And then this will be my answer, right? But we could go ahead and simplify a little bit. So I could see that cosine of x, right? Cosecant of x is actually 1 over sine of x. So this is just sine of x multiplied by 1 over sine of x. The same thing as cosecant of x. Minus cosine of x, cosecant of x, cotangent of x, right? These cancel out, right? These go to 1, right? And I'm running out of room, but my answer will be, let me see if I could fit it here. My answer will be cosine of x minus 1 minus cosine of x, cosecant of x, cotangent of x. So I run out of room here, but this will be my answer, right? This answer is also correct. It's just that I saw that I could simplify that a little bit more, right? Let's look at another one. Y is equal to secant of x over x squared. So again, this is now a difference, and so y prime will be, well, derivative of secant of x is just secant of x, tangent of x, right? Multiplied by pure old x squared, because that's what the formula says. Derivative of the first one times plain old v, right? We could call this u, call this v, right? Derivative of u times plain old v minus, well, plain old v, u, plain old u, which will be secant of x, right? Multiplied by the derivative of v, which is just 2x, yes? And that is all divided by x squared, right? We got to square the denominator, v, we got to square v, right? That's what the formula says. So my y prime here will be x squared secant of x, because you want to always, listen guys, you always want to bring this factor in front, right? You want to bring these factors in front majority of the time. This is the same thing right here, because these are actually being multiplied by this whole thing right here, and so it just makes it look cleaner, right? It just makes it look cleaner. So I'm going to bring my x squared in front. I'm going to have my tangent of x, right? I'm going to minus that from, I'm going to bring this 2x in front, which will be 2x secant of x, right? So this will be my answer. However, I see that I could factor something out. So I could factor out an x, right? You have an x here, you have an x squared here, right? So my y prime will be x. Oh, I'm sorry about that. I'm forgetting my denominator, right? I'm sorry about that. Forgetting my denominator, right? So this is x squared. Anytime anytime you raise a power to another power, or let me rephrase that. But anytime you're multiplying, you're squaring something, you're actually multiplying, and so we multiply these two right here to give us x to the fourth, right? So on the stop right here, I see that I could factor out an x. So this will be x times x secant x tangent x minus 2, right, secant of x over x to the fourth, right? These x's could cancel out. This will leave me with x to the third, right? All right, that's just a pure purpose of factoring out that sign right there, right? And so my final answer will be x secant of x tangent of x minus 2 secant x all over x cubed. Right, that will be my answer. Let's look at the last one. Right, again, this is a difference. And so the formula says, well, the derivative of u times v minus plain old u times the derivative of v all over v squared. Right, so I could call this u, I could call this v. So y prime will be the derivative of tangent, which will be u prime, is secant squared of x, right, times plain old v, which is x, right, minus plain old u, which is tangent of x, times the derivative of v, which is just 1. Derivative of a variable is just 1, all over v squared, which will be x to the second power, right? So simplifying that, my y prime will be x. I'm going to bring this x in front again. It just makes it look better, because you want to be able to tell that that x is being multiplied, even though it's being multiplied there. It just looks better. Right? So x secant squared of x minus tangent of x, because anything times 1 is just itself, over x squared. Right? And this right here would be my answer.